Hello, welcome to our class discussion on the internet. Today is Wednesday, October 8th, and this is the class on the internet, sort of discussion about the history of the internet. As we talk more about the internet and resources and tools and how it's used every day in business, we need to talk about the history and how it got started. So today we're going to discuss that and look at some videos about it as we discuss it. There have been no major changes to the blog. I'm constantly adding the past videos here so that you can watch those if you need to, and the calendar continues to move forward. Again, I do like the blog posts that people are submitting or students are submitting. Some of them are really good. Like them a lot. I appreciate that. And I think some of the other students are appreciating it based on the comments that I'm reading. I've got a couple of students still that are not following directions. Make sure you get the read the blog post guide. And where is it? Down here. So that you must read this so that you make sure that you know how to submit it correctly. Again, here's the calendar, but also this Google Calendar is shooting out messages to everybody, letting you know when posts are due and who's supposed to be submitting them. So let's move on here to class. First question is, what is the internet? Well, we look at the internet connects personal computers, mainframes, all types of intelligent devices. Notice I included soda machines, cars, car alarms. We talked the other day, last week, about Google products and looked at the Google car and autonomous cars, and even dog collars. I also asked the question in class, would you be willing to take a chip? Because one of the classes I'm going to have in the future, in this semester, is going to be a discussion of the Internet of Things. As more and more things connect to the Internet. A refrigerator, washer and dryer, your heating and air conditioning unit. And what about yourself? Would you be willing to take a chip and connect to the Internet? What about your child, if you had some children? Or what about grandparents? That's what we were talking about in class. Some people thought it might be a good idea. Some people said no, but they might take a bracelet or something, but something you could take off, not something you want to implant. All of these computer connections exist for the sake of free information sharing. So we have the globalization of things, shall we say, the globalization of all these devices that can then share information. And you say, well, what kind of information? Again, if you go back and look at your Twitter or Instagram or Facebook, it gathers information as people put up pictures, jot down notes, send messages. And also businesses can use that information. Who owns the internet? No one actually owns the internet. There's no one person or organization. The internet is really comprised of networks that may be owned by individuals, organizations, or companies. But the internet is the network of networks. So the internet is more of a concept than a tangible entity. And because it's a network of networks, there are physical infrastructures that kind of make up the internet. And if you go to the West End Mall and then drive west along Abernathy towards the Kroger, behind that Kroger are some warehouses. And in those warehouses, companies house the computers that represent the physical infrastructure of the internet. You'd be surprised over there in West End back there. Notice how some of those warehouses, if you ever go back there on either Abernathy or on Lee Street, you'll see some old warehouses with barbed wire on top and pretty secure. And that's because they're basically being used to house the infrastructure for the internet. Because back during the Olympics, fiber optics, and a lot of it was put underground along those railroad tracks down there in that West End area, and they're Kroger's. If you go where the Kroger's is located on Abernathy, you'll see some railroad tracks where I believe that's Langhorne Street, dead ends into Abernathy. You cross over there, you'll see this gully with some railroad tracks. Down in those railroad tracks are a lot of fiber optics was laid, and that's why those warehouses are used. How was the internet created? Well, the U.S. military and others started the internet in the 1950s. And I'm going to watch this video about the internet.
The internet in the year 2009. We send emails, make calls over the internet, and discuss topics we take an interest in. Even our banking is going virtual. But what we take for granted today was only a vague idea 50 years ago. In order to understand how we got this far, let's go back to 1957, when everything began. Before 1957, computers only worked on one task at a time. This is called batch processing. Of course, this was quite ineffective. With computers getting bigger and bigger, they had to be stored in special cooled rooms. But then the developers couldn't work directly on the computers anymore. Specialists had to be called in to connect them. Programming at that time meant a lot of manual work, and the indirect connection to the computers led to a lot of bugs, wasting time and fraying the developers' nerves. The year 1957 marked a big change. A remote connection had to be installed so that the developers could work directly on the computers. At the same time, the idea of time sharing came up. This is the first concept in computer technology to share the processing power of one computer with multiple users. On October the 4th in 1957, during the Cold War, the first unmanned satellite Sputnik 1 was sent into orbit by the Soviet Union. The fear of a missile gap emerged. In order to secure America's lead in technology, the US founded the Defense Advanced Research Project Agency in February 1958. At that time, knowledge was only transferred by people. The DARPA planned a large-scale computer network in order to accelerate knowledge transfer and avoid the doubling up of already existing research. This network would become the ARPANET. Furthermore, 3 other concepts were to be developed, which are fundamental for the history of the Internet. The concept of a military network by the RAND Corporation in America. The commercial network of the National Physical Laboratory in England. And the scientific network Cyclades in France. The scientific, military, and commercial approaches of these concepts are the foundations for our modern Internet. Let's begin with the ARPANET, the most familiar of these networks. Its development began in 1966. Universities were generally quite cautious about sharing their computers. Therefore, small computers were put in front of the mainframe. This computer, the interface message processor, took over control of the network activities, while the mainframe was only in charge of the initialization of programs and data files. At the same time, the IMP also served as interface for the mainframe. Since only the IMPs were interconnected in a network, this was also called IMP subnet. For the first connections between the computers, the Network Working Group developed the Network Control Protocol. Later on, the NCP was replaced by the more efficient Transmission Control Protocol. The specific feature of the TCP is the verification of the file transfer. Let's take a short detour to England. Since the NPL network was designed on a commercial basis, a lot of users and file transfer were expected. In order to avoid congestion of the lines, the sent files were divided into smaller packets, which were put together again at the receiver. Packet switching was born. In 1962, American Ferret aircraft discovered middle and long-range missiles in Cuba, which were able to reach the United States. This stoked fear of an atomic conflict. At that time, information systems had a centralized network architecture. To avoid breakdown during an attack, a decentralized network architecture had to be developed, which, in case of loss of a node, would still be operative. Communication still used to work through radio waves. That would have caused problems in case of an atomic attack. The ionosphere would be affected and the long-wave radio waves wouldn't work anymore. Therefore, they had to use direct waves, which, however, don't have a long range. A better solution was the model of a distributed network. Thus, long distances could be covered with a minimum of interference. Another milestone followed with the development of the French network Cyclades. Since Cyclades had a far smaller budget than ARPANET, and thus also fewer nodes, the focus was laid on the communication with other networks. In this way, the term Internet was born. Moreover, Cyclades' concept went further than ARPA's and the NPL's. During communication between sender and receiver, the computers were not to intervene anymore, but simply serve as a transfer node. Cyclades' protocol went through all machines using a physical layer that was implemented into the hardware, providing a direct connection with the receiver, an end-to-end structure. Inspired by the Cyclades network and driven by the incompatibility between the networks, their connection gained in importance everywhere. The phone companies developed the X.25 protocol, which enabled communication through their servers, in exchange for a monthly basic charge, of course. DARPA's transmission control protocol was to connect the computers through gateways. And the International Organization for Standardization designed the OSI reference model. The innovation of OSI was the attempt to standardize the network from its ends, and the channel's division into separate layers. Finally, the TCP assimilated the preferences of the OSI reference model and gave way to the TCP/IP protocol, a standard which guaranteed compatibility between networks, and finally merged them, creating the Internet. By February the 28th, 1990, the ARPANET hardware was removed, but the Internet was up and running.
So as you can see, part of the internet was the U.S. military, but not all of it. So we had other countries provide components that created the internet. How does the internet work? Well, again, got a video I want to show, just about 5 minutes, that talks about the internet and how it works. So let's set up and we'll watch this. Should just take a minute to come on here.
When you use the internet, what happens? Whether you go online to chat with a friend, or send mail, or buy a book, or check the weather, watch a movie, or study the Peloponnesian War, it feels like there's one wire connecting you directly to the thing you want. But a billion other people are connecting to a billion other things at the same time. How does that happen? It's really about making agreements. Think of networking as a game. It only works if we agree to play by the same rules. Otherwise, it's not much fun. If you can get 2 or more computers to play together, you have a network. If your friend can do it too, there's another network. But if you both agree that your networks will play the same way, now you can hook the 2 together. You have an internetwork. The rules we play by are called the Internet Protocol. And as long as we all agree, we can keep adding more devices and more networks until the whole world is connected. That's what the Internet is, a network of networks that share each other. Every device on the Internet has its own unique address. Anything you send via Internet is really just a message from one device to another. But it doesn't travel in one big block. It gets pulverized into tiny packets of data, each one wrapped with info about what it is, where it came from, and where it's going. This way, your one message can actually take several different paths to its destination. Then, by following the protocol, the receiving device knows how to put it all back together. The strength of the Internet is that it's decentralized. With so many possible connections, there is no single point of failure. If one path gets overloaded or broken, your data just takes a different path. Even if a big chunk of the Internet gets wiped out, your message can still find its way. But let's say you use one Internet provider and your friend is on a different one. How does your data really get from one network to the other? Some companies make private connections with each other to exchange traffic. But more and more traffic is flowing through shared service platforms we call Internet exchange points. An Internet exchange is a place where many different organizations come together to interconnect their technology. There may be access providers, broadcasters, publishers, social network sites, telecom operators. Really, anybody who relies on network traffic can benefit from the exchange. By connecting in a common place, they save costs, and the traffic between them flows faster and much more efficiently. Traditionally, providers have sold each other passage on their networks. But for some providers who regularly exchange traffic, all that buying and selling can get to be more trouble than it's worth. Many of them saw that if they just agreed to meet each other halfway, then everybody's costs go down and the traffic moves more smoothly. Providers are able to make a single connection to the platform to exchange traffic with many participants. This way of doing things is called peering, and it's making the Internet faster and more affordable for everybody. The exchange participants make deals with each other according to mutual benefit, so the peering system tends to regulate itself. It may seem like companies are giving away their services, but in fact, each is providing their part of the whole solution their customers need to most efficiently and reliably exchange traffic. The Internet is open, decentralized, and totally neutral. Its intelligence lives at the edge, not in the core. No single organization controls it, and that's why it works as well as it does. By agreeing to cooperate, we all make the Internet happen. And that's how the Internet happens.
Okay. You know what's interesting about this, as we talk about how companies agree to participate and work with each other, we need to consider that also for ourselves in business, and that we need to agree to sometimes work together to get things done. What's going on here? Come on. So, just as the internet works with everybody working together, we need to do the same thing. All right, how does the internet work? Well, there's two different components. One is the internet, which, as I said earlier, is the global network of networks. And number two is the intranet, which is the internal organization network. It may or may not have access to the internet, but you can't get into the intranet without a username and password. I gave the example of TigerNet here at Morehouse. You have access with username and password so that you can go in and check grades, register for class, probably do financial affairs. But not all of that, and TigerNet may have a way for you to log in. So there may be internet access so you can remotely go into TigerNet. But it used to be, TigerNet was first developed, you had to be on campus and go to specific machines because it did not have internet access. But organizations use intranets to control access to sensitive information, company data, communications, maybe information about employees. So we have all these intranets and internets, and some intranets are connected to the internet. How does it work? We've heard in the first two videos about TCP/IP, which is the communication protocol for the internet. So as long as you buy a device that is basically compatible to TCP/IP protocol, it will be able to connect to the internet. If not, it cannot connect. It provides end-to-end connectivity. It's what allows information to flow from one device to another and know how to get there, be routed, where to stop, and who can see it. Also, every device that's connected to the internet has an IP address. It's a set of 4 numbers. Each number is between 0 and 256. Each IP address represents a device on the network or on the internet. For example, here's one. 121.0.23.26. You can, if you want to, you can see whatever device you have, what IP address it currently has. 2 devices, well, let's put it this way. An IP address can only be used on one device that's on the internet at one given time. Early on in the internet, each device had the IP address kind of hardwired into it. But we've changed that because there are so many devices, and now IP addresses can be shared. Not at the same time, but it means that if you're on the computer, if you're on the internet, you have an IP address. Once you get off the internet, that IP address then goes back into the pool and is given to somebody else to use. So some, like Morehouse and big universities, they have a set of IP addresses that they use and that they can hand out to people. As an individual, when you're on the internet, if you're using your phone, you're getting an IP address from T-Mobile or Verizon or AT&T. If you're in your home and you're using your laptop or your notebook or basically your Wi-Fi, then you're getting it from AT&T, Comcast, or whoever's providing you the services. Here's a video I want to show that kind of talks more about IP addresses. Pretty good. Oops. So we're going to watch this video together. Let's skip the commercial.
What's happening, guys? Sean here, Mahalo.com, and today I'd like to explain to you one of the most basic concepts of the internet. I'd like to talk to you about internet protocols. So an internet protocol, or an IP address, is what I specifically like to tell you about. The IP address is your address on the internet. If you were to say your address on the globe, you might give your longitude and latitude. Now your IP address on the internet is simply the same thing. It simply just gives an address of where you are on the internet. To show you what I'm talking about, I'll show you over here. Now, if I were to go to, let's say, I go to 74, I'll zoom in on this for you guys. Let's say I want to go to the IP address 74.125.226.180. This is a complete IP address right here. So we have the first set here. These can be 3 digits here, 3 digits here, 3 digits here, and 3 digits here. So if you just type that in your browser, press enter, we'll zoom out. What the heck? Look at that. That's google.com. You might think to yourself, how did I get to google.com? Well, because we just type in their direct address. And you say, well, I just type in google.com. That's how I get there. Well, that's because they use a DNS, a domain name service. Once you type in google.com, it goes to DNS, and DNS says, hey, that's actually 74.125.226.180. Will depend on where you're coming from. But something like that. Now, another thing too, like I was saying, we have 3 numbers at the front, 3, 3, 3. So you got 12 numbers here. You might be thinking to yourself, well, that's tons of combinations. You could have about 4.2 trillion addresses. Well, you can. 4.2 trillion? What was that? 4.2 trillion addresses, yeah. But we've actually started to run out of IP addresses. What I mean by that is we've ran through those addresses, so there are pretty much none left. That's where they're starting out with IP version 6, but we won't get too far into that right now. Now, I'd like to show you how to find your IP address. So on the computer, you can just go to a website, whatismyip.org. Here we go, whatismyip.org. So for some reason, you need to find out what your IP address is, you can just go to that website, and boom, there's your IP address, real simple and easy to find. So, this is my longitude and latitude, if you would call it that, on the internet. And you can also call it like 123 Main Street in wherever, some town, Minot, North Dakota. 123 Main Street, Minot, North Dakota. That would be the equivalent of your address. So that's what your IP address is. And it's not really, it doesn't hold too much information as far as anybody like, oh my gosh, you found my IP address. Not too big of a deal. Your internet provider, your ISP, provides it to you, and that's your address for connecting to the internet. So I hope you learned something here today, guys. And if there's anything else you'd like to learn, send me a request. Request at mahalo.com, and thanks for watching, guys.
All right. Again, that talks about IP addresses and the importance of them. Again, he mentioned something called DNS, Domain Name Services. And it's a database that translates domain names into IP addresses. So when you type in, as he was saying earlier, a domain name like google.com, that goes to the Domain Name Services database, and it's translated into an IP address, and then you're sent there. So you use a service like GoDaddy and buy a domain name. That domain name is then going to be connected to an IP address. That IP address is where your website is hosted, or wherever you want that domain name to point to. So they will give you, if you go to GoDaddy, now in my case, when I use hba322.info, I'm pointing that to another domain name, which is with Blogger, and then Blogger has the address of this blog for the class. How it works, often used domain names is, it serves, it's like a phone book for the internet, and it translates user-friendly names into IP addresses. For example, you see down here at the bottom, yahoo.com, which is 69.147.76.15. It would be a lot harder if we didn't have domain name services, because you would have to use IP addresses. And who can remember all of these numbers, or all the numbers that you would need? So if you had to go to the blog, For this course, you'd have to remember those 4 sets of numbers instead of hba322.info. So domain name services are very helpful. Next, how does the internet work? Well, any intelligent device, as we said earlier, can connect to the internet. Home networks are allowing devices to connect wirelessly, and this is creating demand for intelligent home devices. This Internet of Things that we talked about. With Wi-Fi networks popping up all over the place. You can go to fast food restaurants, you can go to sporting venues, and you see more and more Wi-Fi's allowing people to just hook up to the internet. Business activities and communications are moving to the internet because of its speed and low cost. As you know, all businesses, they're moving of course they have websites, they're using social networking, you can buy and sell. As we talked a long time ago in this class of the difference between moving from the information age or the industrial age to the information age, we were moving from an analog environment to a virtual environment. The internet is that platform for the virtual environment. And more businesses and individuals are using that platform because it increases speed and lowers cost. So over the rest of the semester, we will visit these services that have moved to the internet or being created because of the internet. You look at services like UberX. I was watching something on that the other day, in which they were talking about the internet is going to allow for more shared resources among people. As I talked earlier about the autonomous car, I can see one day where people don't have their own cars. Everybody just shares a car. Just like you don't have your own IP address. You just get an IP address whenever your device needs to get to the internet. Well, you can imagine one day everybody's sharing cars. And basically, you just need a car whenever you need to jump and go somewhere. If I need to go to the grocery store, I would, before I take my shower, maybe contact whoever the provider is of a car and make sure that car is delivered to me in time by the time I want to go to the store. So that's a quick discussion of the history of the internet, kind of how it works, the DNS services, IP addresses, the history of it. So just to kind of get an understanding of it. There will be a quiz on this, which I'll open up tomorrow. There's currently a quiz concerning Monday's class, which was Excel number 3 and tables. Again, people are continuing to submit their blog posts and are doing a very good job. I like it a lot, and so I want everybody to just keep it up. You can see the most recent one, or one of the most recent ones, by Mr. Cunningham. Don't forget that comments. Again, check your Schoolology. I've got a couple of grades I need to update on that Schoolology, so give me a little time. I'll do that and get that done. Again, thank you for attending class today. The quiz or exam for this will activate tomorrow. And have a good weekend. Take care.